In this video, we are going to be looking at measuring the rate of reaction by collecting gas and measuring the gas volumes. So we're going to be investigating the effective concentration of hydrochloric acid when it reacts with magnesium on the rate of reaction. This is the equipment I'm using. Let's have a closer look to see how we set it up. I'm going to be using two different concentrations of hydrochloric acid in this demonstration. So I've got 1 moles per dm cubed and 0.5 moles per dm cubed to see what effect they have on the rate of reaction. The magnesium is in these strip forms. Now ideally these should be measured so that they are exactly the same length, so that they should have approximately the same mass, an important control variable in our investigation there. I'm going to be using a 10 centimetre cubed measuring cylinder to measure out the acid. The reason I'm using a 10 centimetre cubed measuring cylinder is because I'm only going to add 10 centimetres cubed of acid into the boiling tube. So we always want to choose the smallest measuring cylinder that will fit in the volume that we're measuring. And that means the measuring cylinder will have a higher resolution, which will help to reduce the percentage error of our results. I've got here 2 boiling tubes that will contain the reacting mixture. Over here we have the bung that will go into the boiling tube, and this is fed into the water container. And the tube is inserted into the top of the burette. The reason we're using the burette is a similar reason to the measuring cylinder. This has a much higher resolution compared to just using a 50 centimetre cubed measuring cylinder, so that allows us to get more accurate results. This has been inverted and it's been filled with water. You might notice that the water level is slightly above the 50 centimetres cubed mark. So what we would do is just open the tap of the burette slightly and slowly release that water out until the bottom of the meniscus lines up with the 50 centimetre cubed level. Now it's time to actually carry out the reaction. So I've measured out 10 centimetres cubed of the 0.5 moles per dm cubed of hydrochloric acid in my measuring cylinder, making sure that I used the pipette and got down to eye level and added it drop by drop at the end. I've got 2 strips of magnesium, so I'm going to add the acid into my boiling tube to start off with. And the next bit is really important you do as quickly as you can. So I'm going to be adding 2 strips of magnesium. As soon as they go in, I'm going to insert the bung into the boiling tube and start the timer. So if you're working with a partner, this becomes much easier because as one of you adds the magnesium and puts the bung in, the other one can start the timer. Let's have a look. So bung in straight away, start the timer. And so the magnesium will be starting to produce hydrogen gas. That will start to bubble through the delivery tube, and as the gas bubbles through the delivery tube, it will push the water out of the burette, and we can measure at time intervals, for example every 10 seconds or every 30 seconds, how much gas has been produced. So we can see we've got the first couple of bubbles starting to come up now. It's important that you have a tight seal around your bung and a tight seal around your delivery tubes so that no hydrogen gas escapes. It's always useful as well to do a preliminary investigation so that you can see what time intervals you are going to use. For example, with the 0.5 moles per dm cubed, it's bubbling quite slowly. So we could probably measure the volume of gas being produced every 30 seconds. So I've reset my equipment, I've refilled my burette with water, and now I've measured out 10 centimetres cubed of the 1 moles per dm cubed of hydrochloric acid. So again, I'm going to add this into the boiling tube first, and then very quickly I'm going to add my 2 pieces of magnesium, put the bung in, and start the timer. So bung goes in quickly and start the timer, and you can see already we're getting significantly more gas being produced within the first few seconds, and the number of bubbles we can just see coming up is much more in the first few seconds. So we can see qualitatively that the 1 mole per dm cubed is faster, but we'll be measuring every 30 seconds or every 10 seconds the precise volume of gas that is being produced. And so what we're going to look at in lesson is how we would draw a graph to show these results, and how we can calculate the rate of reaction at different time points during this experiment. So that's a summary of a practical method you can use to measure the rate of reaction by collecting the gas volume of hydrogen produced. And you also need to be able to draw graphs of these results and also explain these results in terms of collision theory and also the Maxwell-Boltzmann distribution graphs. Hope you enjoyed the practical. I'll see you next time.